today I'll be going over the basics of multislotting. Multislotting is somewhat advanced, so I assume in this video that you have a decent familiarity with F2L and the formation of pairs. Furthermore, I strongly suggest that you first watch my partial edge control video before continuing with this, as the two techniques are very similar. Multislotting is almost just an extension of partial edge control. It's similar to partial edge control in that you insert F2L pairs in specific ways to simplify the following step. However, this technique primarily differs from partial edge control with when you use it. While partial edge control is used while inserting your last F2L pair, multislotting is used while inserting your first 3 pairs. It's more difficult than partial edge control because you have to worry about more pieces. Instead of only thinking about the orientation of the last layer edges, in multislotting you have to keep track of the orientation and positions of multiple pieces, namely the pieces that make up the F2L pair that you will be solving next. With this technique, you use all the same triggers as you do with partial edge control, which are R, U prime, R prime, R prime F, R F prime, a sledgehammer, and R, U2, R prime, plus all their mirrors. In addition, you can also do M prime U, R, U prime, small r prime, and its mirror. As you can see, it affects the last layer very similarly to a sledgehammer, except that it changes a couple corners differently. As I've already mentioned in my partial edge control video, each of these triggers, when used for inserting a pair, results in a different last layer. So, while solving your first 3 pairs, you can modify the way in which you insert the pair to set up and simplify your next F2L case. For instance, in this situation, instead of inserting the pair with the usual U, R, U prime, R prime, which gives a fairly bad case for the next pair, you can instead insert it using a sledgehammer, which also joins the pieces to the next pair, resulting in a much better case. Here we can join the pieces to the next pair while inserting by doing U2, R, U2, R prime. Then we can easily insert it like that. As another example, here inserting this pair normally gives a decent case for the next pair, but also one that requires a cube rotation. Instead, doing U2, R, U2, R prime sets up this pair, but again we have to do a cube rotation to insert. Doing a sledgehammer gives a decent case and does not require a cube rotation. However, doing M prime U, R, U prime, small r prime gives a much better case and also one that does not require a cube rotation. Now that you should have a good idea of how you can use multislotting in your solves, I will talk about how to find the best trigger for any particular case. As with everything that I've talked about in this series so far, I will certainly not be going over every case. I'll leave that up to you to figure out for yourself. However, I do have some tips for learning these solutions. For this, we need to analyze how each trigger affects the last layer differently. More specifically, we should look for which blocks of pieces stay together and which split up while executing a trigger. You may find this intuitive, but I will go over it nonetheless because it's extremely important in multislotting. It's easiest to visualize these effects by simply doing the inverse of each trigger from a solved state. For example, for the standard trigger for insertion, which is R, U prime, R prime, you can visualize its effects by doing R, U, R prime, its inverse. Looking at it, you can see that after executing the trigger, this 2x2 block is preserved, as are these 2x1 blocks. The rest get split up. Doing the same for a sledgehammer, you can see that this 2x2 block, just like with the standard trigger, remains intact along with these 2x1 blocks. For the trigger RU2 R prime, we can see that this 3x1 block stays together along with this 2x1 block. Everything else gets split up. As for M prime U, RU prime, small r prime, you can see that this 2x1 block stays together along with this 2x1 block. The rest gets split up. Of course though, I've only talked about which pieces split up. You should analyze these triggers on your own in more detail. That is, figure out exactly how the pieces split up, how they combine, where they move, and how the orientation of the pieces change. I only talked about how the pieces split up and stay together for the sake of simplicity. There's much more to learn about how these triggers manipulate all the pieces, so experiment with this. You can do this by doing what I already showed you. Do the inverse of each trigger and look at the resulting positions and orientations of all the pieces. That said, knowing the little that I did show you, you can do some basic multislotting already by simply splitting up difficult pairs and preserving good ones. For example, if you want to split up these 2 pieces, you simply have to think about which trigger does not preserve this block. In this situation, that would be a sledgehammer, which gives a somewhat better case than any of the other triggers, each of which would have preserved that pair. I once again strongly suggest that you experiment with this technique. It allows your solve to become much more efficient, and thus it can be tremendously helpful overall. If there's enough interest, I may make more videos on the topic on my own channel. That said, that is all for this video. Make sure to like this video and check out my channel if you found it helpful. Thank you for watching, and I'll see you next time.